Hey everybody, this is Larry. This is me going Q4 of the Biweekly Contest 106. Find a good find a good subset of the matrix. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And I'm here in really sunny Tashkent in Uzbekistan, trying to do a contest live for the first time in like a month or something. I don't know, but yeah, let me know what you think. But the first thing to notice is that C is equal to 5, right? You look at the constraints and C is equal to 5. What does that mean? I don't know, to be honest, but it's just something to kind of note when you look at constraints, and it's something to be like, okay, well, it sets you up for different types of problems. For me, it didn't really set up precisely yet. I thought there's some like power set thing, which is like 2 to the 5 or something like this, that we can use. And it was dynamic programming, but then I think I just misunderstood the problem initially. The key observation is that this is very tricky. So the key observation, and this took me, I don't know that I convinced myself during the contest. I think I just kind of did try a lot of examples and couldn't figure it out, is that the answer can never be 3 or higher, right? So the answer is 0, or not 0, I guess, because depends if you want to count that impossible as 0. But the answer is either impossible, 1, or 2. If a row is all zeros, then you have a 1 answer. I mean, I think this one is obvious. Maybe I don't have to prove because by definition, and they even show it to you a little bit. The second part is that if the XOR of two numbers is equal to 0, then or 2 rows is equal to 0, then you have two rows as the answer, right? For example, you have something like this, and it doesn't have to be precisely, maybe not 0. Sorry, I said that wrong actually. But basically, something like this would be a good double, right? Because now for each row you can find almost rough complement, and this is 6 rows, so that's not even possible, but or not within constraints. So you have something like this, and that's good because now, each of these ones is not the majority, right? Hopefully I don't have to go through this one. I mean, I think this one makes sense as well, because then now, this is good, and so forth, right? This is good because now, that's just by definition, and there are ways to do it. We'll go over it in a little bit. The way that I want to say in my head, I kind of prove by contradiction, in that if there exists a thing that needed a 3, well, 3 cannot exist because that would imply that by definition, half of 3 is 1, round down, because you can't have 2 things of a 2. So if you have 3, then 2 should also suffice, because of just like how you want to structure it, right? Hopefully, I don't think that I'm saying that quite right, but 3 cannot be possible, because if there's an answer, or like if you have a thing where 3 is a solution, you can actually only take 2. I don't know if it's any 2 of these. Yeah, you can take any 2 of these, and it will give you an answer, right? Why is that? Because by definition, it means that 3 is not. I mean, it's not that it's not possible, sorry, but it's just that 3 is not necessary, right? Because I guess this one is not about minimal, so you don't have to return the minimal. But 3 is not necessary because that means that each column has at most 1 1, but that means that if you take any 2 of them, each column still only has 1 1, right? If you only take 2 rows, each column each column has at most 1 1 still. Makes sense, because that's how sum works. And so the two of them is also sufficient, right? So that means that you'll never find an answer where you could have 3 but not 2. And I think you could kind of maybe do this by induction in that way, because if you have 4, then you could deconstruct it in a way such that you can only use 2 of them. Maybe not any 2, but definitely 2 of them, because I think you could do it by like exhaustive, right? Because basically, for example, what's 4 choose 2? 4 choose 2 is 6, right? So there's only 6 ways. So you have right, 6 possible ways, and in each of these 2 ways, if you choose any 2 of these numbers, then it should be good. And yeah, there shouldn't be a case where you can construct a number that requires 4 but not 2. Like I think maybe the closest thing is like something where you can construct like like you need something to balance it out. Like maybe you can think about like doing something like this. But in this case, wait, is that true? Oh yeah, but in this case, you can just take the 2 that doesn't, you know. So there's always a subset of the 4 that kind of complements. So you should be okay. So that's basically the answer. And once you have 2, once you accept that 2 is sufficient, then now you can search for 2. And the idea behind searching for 2 is that, you know, as we said, let's say, you know, we keep track of the numbers we've seen, or the bits that we've seen. So we have something like this, and we want to search for basically, so this is one of the numbers that we can search for. We can also search for this. We can and then right? Basically, the subset of the complement of the number. And that's basically the idea, right? So that means that we have any of these 4 things, we have a pairing. Of course, it's not really necessary because, or like one of them is not necessary because obviously if it's 0, then you already have the answer. And yeah, and here you can figure it out that way, right? So yeah, so this is my solution. I keep track of what I've seen. This is just converting it to a bit mask. If the exact complement's already in this, I return this sort of thing, or it's not really necessary per se. I could have removed this, but this basically just gets the subset, the power subset of the bit mask. It runs it a little bit faster. It's 3 to the n instead of 4 to the n, maybe, or something like this. But in total, but it basically, yeah, just flips each bit instead of every bit. So yeah, and basically if we don't find a match, then we set the index, and also if the current thing is equal to 0, we just return. Maybe I could put this up there for a little bit of optimization, which is really not necessary. But yeah, this loop, even if you did it more lazily, it's going to be at most 2 to the 5th. This is linear, so this is going to be O of R times 2 to the C. Which is going to be fast enough for this one, right? Why did I do it this way? It took so long to kind of optimize this. But anyway, this is the time, and space is just O of R, because 1 for each row, and that's pretty much it. I mean, this is just sorting 2 numbers. I kind of, you know, didn't want to make a silly mistake on it. So yeah, on ascending order. You know, it looks very awkward. But anyway, yeah, that's all I have for this one. Let me know what you think. The hardest part is about the proof. Once you realize you can do it with two rows, then everything is simple for some, you know, in some way, or you can figure it out anyway. So yeah, let me know what you think. That's all I have for today for this problem. You can watch me yourself in live during the contest now. Say, okay, how am I doing? 17 people got it wrong already, so let's take a look at the standings real quick. And it doesn't really say. So, 256. I don't know, maybe that's good, maybe that's bad. All right, we have a matrix. Sum of each column of the subset is at most half of the what? I think this is just tough to read in general. Okay. Sum of each column of the subset is at most half of the length of the subset. Let's take a look at the n first. 10 to the 4. N is 5. Is 5 the number of row or columns? Number of rows m, number of column is 5. Okay, that's something to interest about. That should be doable, but okay. So this is that's the column, right? That's why I wish they use R and C. It's so confusing sometimes. Okay. Right, and then sum of each column. The length of the chosen subset of rows is k. Length is such a really weird. It's by the way, friends, there's no length in a subset or a set in general. Technically, it's the cardinal, but you should use like things like count because it's more precise. Length is not quite it's not quite formal, if you will. But that's not the point, I suppose. I mean, I mean, there's, I mean, it's supposed to 5 columns when we would cache on that, right? So there's just 3 to the 5th or something like this. 3 to the 5th times n or something like that, right? 3 to the 5th times n, 10 to the 4th. What's 3 to the 5th? 3 to the 5th is 243 times. This is one of those things that Python is going to be sad on, maybe, possibly. And I'm like thinking about it. But oh wait, is that true? Maybe I'm confusing it. So there are 3 columns. Length of the subset. Oh wait, no, that's maybe wrong. Okay. Because I was thinking about the length of the columns. Like I said, the length is such a weird thing to say for about sets. The sum of each column. Okay. Only 5 of these. Should be able to abuse this, right? 3 people abused it. If you choose 1, then this is the half of it is 1. So okay. So then you want the delta. Oh, and you have to return the subset. Oh, you have to return any good subset, not the best or okay. So it's a construction farm, constructive farm. All right, that's a little bit different. I think of each one as delta maybe, but that's, can we sort? So okay, so if you add a thing, then you definitely need something else to balance it out. So at most 5, right? This is, stuff like this is never good to use. So basically we want, and the only ones anyway, but let's see. How am I thinking about this? Okay, what is the worst answer, right? In theory, the worst possible answer, let's say this, right? And then you do something like this, and then maybe something like this, but then you just do this, right? So is there, okay, so the only possible answer for 1 is just something like this, and then 2 is something that is complementary, right? Is there an answer for 3? Because by definition, for 3, is there an answer for 3? Let's say we have something like this, that doesn't make sense because you would just never use it, like we said. So basically, maybe something like this. So that's 2 still. Let's say we have this and then this. But then now we need something like 2, right? So then that doesn't even make sense. Is there a possible answer for 3? I don't know that I can prove. Because it's not like you need to do everything. Is there a possible answer for 3? 5 people got it. Let's just add another one just for fun. So, but then now, by definition, we need something like this. Almost like this. So I don't think 3 exists. So let's YOLO this real quick. Grid of ij. Right. Return. Oh, whoops, that's actually incorrect. Oh, and also you don't need to minimize, Larry. So if this is the case, and then I sort it. Did I do the first one? Oh, this isn't quite right because it doesn't have to be matched. Right, what it needs is power set of this. But if that's in it, that's fine, but okay, let's say that that's not the case, then just do the power set. I forget how to write this. Something like something like this. I don't know if that's right. I can't find it. It's been too long since I've written it. Anyway, now if is that not how to write it? Oh, jeez. Should have been done with this already, but I'm just too new. I don't even know what this went from. Is that right? Still not right though. Okay, so it's over 1 and 0. Subset of that. Should be good. Why not? Don't tell me why. Okay, so 1. It does 12. This should be 4 and 2, so 6, right? So 6. Oh, I'm an idiot, because I have to put synchron is equal to I. Wow, I've been debugging for so long because I forgot to put in the critical bit. I mean, I don't know if this is right, to be honest, but YOLO, I guess, because I can't prove it. So it's probably wrong though. So, but I also just forgot that much. That was a silly mistake. Silly. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, the explanation, this contest, whatever you feel like talking about. Yeah. Goodbye from Tashkent. I'll see you later. Stay care. Stay good. Stay healthy. To good mental health. I'll see you later and take care. Bye bye.